I noticed about this time yesterday. This is my last I thought if I didn't use it for a while, you'd find it seems got worse. So I think it probably had something to do with Oxide when I was sparring with my partner for US Ultimate Fighting. I think I might have hit someone too hard. So, yeah, it's important to basically. It's important to pace yourself in Muay Thai. So,
do you want me to record?
It's recording right now. All right. So, ladies and gentlemen, last week we did a bunch of mole-mole calculations with limiting reactant, and today we're going to add the important steps, going from moles of something to grams of something else. And then going from grams of one thing to grams of something else. This is really the most important part of stoichiometry. And probably many of you are going to find it the easiest too, because it follows the system. So first one we'll do together. How many moles of O2 with plenty of excess H2 are required to produce 12 grams of water? So we need, what do we need to do any kind of stoichiometry? We need a t-chart, we also need a We need a chemical equation, exactly. And that chemical equation is what happens when H and O react together to form H2O. Is this a balanced chemical equation? No. No. What do I need to do to balance it? 2H2? So 2H2 and 2H2O, and we're balanced. So we're going to do a t-chart. We're going to do a t-chart. And do that. Now, reading the exercise, what is my given value? 12 grams of H2O. My given value does not have to be a reactant. It could be a product. In this case, it's a product, and we want to know how much is required to make it. So we're going to start with our 12 grams of H2O. H2O. Now at this point, it's important I mention something, because I've been doing this for a long time. Every spring, or actually every January, I do this stoichiometry, and I walk you through. And every January I say the same thing, and a whole bunch of people will ignore me, and I'm almost to the point now when they ask me a question and they're not showing the proper work, I'm just going to ignore you. I'm almost there. I'm not quite Bandolero of Dynamite there, but I'm almost there. So here's what every box in stoichiometry needs. A number, a unit, a label. Every box in stoichiometry needs a number, a unit, and a label. So if you bring me stoichiometry and you're like, I don't understand why I got this wrong, and all you have is numbers, I'm not going to help you. Because I'm tired of saying the same thing over and over again. Every box needs a number. Everybody likes a number. But it also needs a unit and a label. 12 grams H2O. That's because you need to make sure your units and labels cancel out. If they don't cancel out, you're setting it up wrong. And what a lot of people do is they throw a bunch of numbers and like, how did I get the wrong number? I have no idea, because I don't know what your numbers represent. So you have to show your number, your label, your unit. Am I being clear? Yes. Cool, I think I beat that horse enough. All right, so 12 grams H2O, what goes down right there? Nothing. Nothing. Nothing, because it's just 12 grams. Now, I got my 12 grams, what's my next step? Bring down what?
2 grams. H2O.
Grams H2O. Do I bring down 12?
No.
No. Now, what am I converting to? Be careful.
To moles.
Moles of?
O2.
No! Moles of H2O. I need to convert to moles of H2O. Why do I need to convert to moles of H2O?
Find the grams.
So I can turn it into oxygen. Right, I can't remember which of you, so I'm going to skip
Me too.
No, you got it wrong. No, I'll give you some. At least you spoke up. There you go. All right, so I have to get my water to moles. That's the only way to change chemicals. I'm starting with water, I'm going to oxygen. There's only one way to change chemicals, and that is with the mole ratio. Am I being clear?
Yes.
Is there any way to change chemicals besides the mole ratio? No. Is there a gram of water to a gram of oxygen? No. Is there a mole of water to a mole of oxygen? Yes. All right. So we're going to go get this to water. Now I need to be able to convert my grams into moles. How am I going to do that?
You're going to take the unit for the chemical equation and put it in the bottom, right?
No. Gram to mole comes from only one place.
Molar mass.
The molar mass, exactly. The gram to mole comes from the molar mass. Do you have braces?
No.
How about some flavored sugar?
Oh, it's
All right.
Already opened.
Sugar and flavor, 2 ingredients. Boom, done. All right. So what is the molar mass for water? 18. So 16 for the oxygen and 1 plus 1 for the water. So for every 1 mole of water, we're going to have 18 grams of water. Okay. So hey, cool, that's neat. So am I done? No. So I'm not done. So I'm going to make another line right there. And I'm going to bring down my moles H2O. And now that I have moles, now I can convert chemicals. I got moles of water, now I can convert to something else, and I can put my moles of oxygen up here. And for this, where does the mole to mole come from? The mole ratio. The mole ratio comes from the balanced chemical equation. Gram per mole comes from the periodic table, the molar mass. Mole per mole comes from the balanced chemical equation. So oxygen gets a what number? 1. And water gets a 2.
Right.
Now, why do I tell you that every unit or every box has to have a number, a unit, and a label? Because they should cancel out. The only thing you have left, the only unit you have left should be your goal unit. It should be the what is the, how much is the, calculate the, find the. It should be that the. And in this case, the is how many moles of O2. The only unit that should be left is moles of O2. So let's take a look. Grams H2O, does grams H2O cancel out anywhere?
Yes.
Down below. So grams H2O cancels out there and there. Moles H2O, does that cancel out?
Yes.
Yep. Moles H2O, moles H2O. Moles O2 is the only thing left, and that is our goal. So that is going to be our last unit and label in our answer.
Wow. She's really good.
Excellent. The sense was what I was going for. Now, a lot of you be like, I got this, I ain't going to show it, no problem. Then you get it wrong, you bring it to me, and I look at you, and I said, remember what we did on January 27th at 9 o'clock? Yeah. Remember that? I said I was going to help you. I ain't going to help you. All right. So now we do some math. The math we're doing is 12 times 1 times 1 over 18 times 2. You don't have to put the ones in if you don't want to put the ones in. It's 0.3? I'm told it's 0.3. 0.3 moles O2?
Yeah.
I don't know. You guys got the calculator, not me.
Yeah, I'm talking about that.
Okay. So if this stuff makes sense, or what we just did together makes sense, give me a thumb up. If you want me to walk you through it, wave your hand around. All right. If that's the case, then let's try this one. If you react 3.5 moles of HCl with 2.3 moles of zinc, how many grams of zinc chloride will you produce? Oh no. I'm given 2 reactants. What do I do? 2 T-charts, exactly. If I got 2 reactants, I'm making 2 T-charts. I'm also going to turn on the lights so you can see your calculators and I can see the board. So again, if we need a chemical reaction, it's one of my favorite chemical reactions. This is what happens when zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. I love it. Is it balanced? Go ahead and balance it on your paper if it's not balanced. Yes.
Wait. Oh, it's, I know what it is. 1, 2, 1, 1. 1, 2, 1. 1, 2, 1, 1.
1, 2, 1, 1.
Yeah,
1, 2, 1, 1. 1, 2, 1. Okay. 1.
I think. Yeah.
Well, we'll always check our work. 2, 1, 1.
Yeah.
All right. So let's see.
There's one VN.
1 zinc, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. Would you like a candy?
Yes, please.
Flavored sugar?
Sure.
I reloaded, so all the good stuff's on top. The bottom is like a bunch of Tootsie Rolls, but the good stuff's on top. All right. Tootsie Rolls? All right, so there's our balanced chemical equation. Ladies and gentlemen, can I erase this from the last exercise? Yes. All right. Now, you might notice, this is important, guys, you might notice that 2 reactants were given. Oh no! And somebody said, when you have 2 reactants, what must you do? 2 T-charts. You gotta do 2. So the first T-chart is going to start with 3.5 moles of HCl. And the second T-chart is going to start with 2.3 moles of zinc. Nothing. Kind of do like that. Like kind of just got shocked. All right. Oh, yeah. Good. 2.3? Yeah, I'm barely see it. 2.3. So let's go to work on the top one. What should I do with my moles of HCl? Bring it down. Bring down my moles HCl. And to what am I converting my moles of HCl?
Oh, I know.
Moles of
ZN
chloride. Right. Moles of zinc chloride. So I'm going to convert my moles of HCl to moles of zinc chloride. Again, I've got moles. There's no reason to go to grams of HCl. Don't need to. So we're already at moles, so let's just use our moles. Cool. Can we do the same thing down here?
Yes.
Right. So bring down our moles of zinc and convert it to moles of the zinc chloride. Cool. That's neat. Where do I get these mole-mole ratios?
In the problem.
No. From the balanced chemical equation. The balanced chemical equation to zinc HCl is what? What's the numbers I should put for CNTL? 1. And HCl? 2. And zinc chloride? 1. And zinc? 1. Cool. All right. Am I done? I've converted to moles. No. Smarties coming at you.
If we intercept
I'm
one,
getting really good at throwing tiny pieces.
if we intercept one, can we keep it?
No. Okay, so what's my next step?
You convert the moles of zinc chloride into grams.
Yeah. So in both cases, I'm going to move down my moles of zinc chloride, and I'm going to convert that to grams of zinc chloride because that's what it's asking for, grams of zinc chloride. Hello. Immediately to the details.
Bye, Laura.
Bye. Wow. All right. So, gram per mole, where does that come from? Where does a gram to mole conversion come from? Yeah, periodic table. So, go ahead and finish these 2 guys up. And when you have your molar masses and you have your answers, let me know what you think is CP2 right there. Show your neighbor. So when you got your answers, you got your molar mass, show your neighbor, and we'll see how we're doing.
So once you write it all down, this is like, what is it? Jagger. Okay, what?
Just wrote down. There's no numbers.
Make sure you write fixed on it again. Where did I put this one?
Again, when you got your answer, show your neighbor and see if your answer matches your neighbor's answer. Make sure your neighbor's unit and chemical matches your unit and chemical.
Wow, she's good.
Oh my god.
135 molar mass? 136. 136? All right, so I take it from the chatter that you guys are done?
Yes.
136 gram per mole for the molar mass? All right. So if HCl is the limiting reactant, if it is, then how much zinc chloride do we make?
238.5.
238 grams of ZnCl2. And if zinc is the limiting reactant, how much zinc chloride do we make? 313?
Yes.
Let's try that again. 313 grams of ZnCl2. So, which one's the proper answer?
238.
238, yeah. 238. Again, the limiting reactant is the one that makes the least product. So the correct answer is 238 grams of zinc chloride. Okay. If you're with me and you have a pretty good idea what's going on, give me a thumbs up. If you want me to go over it again, wave your hand around. Okay, we'll go over it again. All right, so we've got, from the top, we've got two reactants at 3.5 moles of HCl and 2.3 moles of zinc. Okay, got two reactants. We're going to make two T-charts. In both T-charts, we're going to start with each reactant, and we're going to go to grams of zinc chloride. Moles comes down. The mole ratio tells us we can change to the chemical using mole to mole. Once I've got my chemical changed in moles, I'm going to convert it to grams. So moles of zinc to moles of zinc chloride. Bring the moles of zinc chloride down, convert it to grams, and we have now the unit that's left is grams of zinc chloride. Again, we can cancel out the unit. Moles HCl, it can be canceled there and there. Moles of zinc chloride can be canceled there and there. Moles of zinc can be canceled there and there. Moles of zinc chloride can be canceled there and there. The unit that's left is grams zinc chloride, is what we're looking for. Then we do the math. The one that is least is the answer.
I followed you all the way, but I don't know how you got the 238. I don't know what math you had to do.
The math was 2.3 multiplied by 136 all over a bunch of ones.
And that's for the same.
That's for this one. And the math up here was 3.5 multiplied by 136 all over 2, and that's that. So once your answers are done, it's kind of like a giant fraction. How are we feeling about this? You okay, Andrew?
You dying?
Don't die on us. All right. This one's for you.
This one is for you.
This one's for you, team. If 4 moles of Fe2O3 react with excess aluminum, how many grams of iron will be produced? So I'm going to go ahead and give you the chemical reaction. This is the chemical reaction of aluminum oxide. Wait a minute. Aluminum makes aluminum oxide. Aluminum.
Can you just give us the answer?
No. Plus Fe2O3, that's iron oxide, makes iron metal, yay, and aluminum oxide. Okay. So this is thermite. So I'm going to go ahead and stop the camera, and you guys are going to work this through, and then when you have an answer, show your neighbor, and you can see what's going on.
No.